but what we're going to talk about is what is MLOps and what is the maturity framework and how do you sort of achieve something like this with Vertex AI. We're going to go towards the operation side of things and we're going to learn why MLOps is important and why do we really care about that in the first place. This is a very common thing that I'm pretty sure most of you would have heard or somebody might have mentioned to you that most of the projects in data science don't go into production. And that's pretty much what we're trying to address with the MLOps framework. So this is still a very ongoing work which a lot of big companies are doing. Google is one of those companies which have pushed thousands and thousands of models into production. So what we're going to talk about from a maturity point is essentially what they have been doing with the models and how you can leverage the same at your end, right? So this is your typical thing that you do right now, where you go through the manual experimental steps on a notebook, you train the model, and then you sort of just deploy. Now, one of the things that you notice here is that deployment here refers to just having an API or maybe building something based on Flask or something like that, right? That's pretty much what most of us do at this point when we do machine learning or machine learning deployments and things around that, right? But we need to think about why does this break in the first place. So before I go in details and talk about why it breaks, can anybody tell me in their experience why this pipeline sort of fails or it doesn't give you results? I think what you're talking about is towards that side of the system. So wherever you're integrating your machine learning, there could be thousands of things that could go wrong. And that's true, but I'm trying to sort of focus on the left side. What could go wrong in this? Data drift, yeah. The data can change, the bias can incur because your data are not sort of consistent, right? It keeps changing, you get new data. All you do here is you're essentially taking a snapshot of something which is historical and then sort of training around it. Now, if you do have issues like data bias and data drift and all of those, the current solution that most of us do is essentially we sort of retrain everything manually, right? We go through the whole notebook that we have built and we just sort of do the whole step one more time. The problem with this is, and this is where the problem that we'll try to address is that this doesn't scale. And you can rightly think in your mind as well that if my data changes with high velocity, I would have to do that step again and again, again and again. So we need automation. So in a very simple term, if I have to say, and we'll come to the official sort of so-called definition of it, but MLOps sort of deals with what different kinds of automations we can do in the process of data science that we deal with, right? So that's pretty much what it is. Now, because it's subjective, every company can have their own process of automation. It's not set in stone. So whatever we'll study is not something that you have to exactly do. And that's why we call it as a framework more than like a technology or a tool. So MLOps is not a tool, right? It's not like a single tool that will solve everything. These are some of the struggles that I'm pretty sure most of you go through. But let me come to the MLOps definition. MLOps is ML engineering culture and practice that aims at unifying a set of standardized process and capabilities for building, deploying, and operationalization ML systems rapidly and reliably. Anybody who can explain me what ML engineering means here? Just a rough guess or maybe based on your experience. So it's some kind of an automation. So rather than sort of again writing the code manually in the Jupyter notebook and running cell one by one, you sort of come up with some kind of an automation saying that, hey, I have a script that sort of runs through a bunch of pre-processing steps of my data. I don't have to run through individual cells, right? So all of that, so the data engineering is separate. The ML engineering sort of deals with the moment you do the model and everything to do beyond the model, right? Because your data part will be covered in the data engineering side. More often than not, again, from a confusing perspective, a lot of people also say that data engineering is part of ML engineering, right? Because ultimately, when you have to deliver models, both data engineering and ML engineering has to come together. So let's see how do we sort of summarize this from a very high level. So just like I said, you try to automate all of this. So you have machine learning where you do data processing, model development, metric evaluation, the development, and we'll talk about CI/CD in a moment. Doing the integrations of the model, latency calculation, monitoring of the model, user feedback loop, model delivery. Here's one which is very interesting keyword, which is user feedback loop. Can somebody explain what this is? Like, just give it a guess. What could user feedback loop mean? You've all seen a great example of this if you have seen ChatGPT function, because the layer of ChatGPT, the front end of it, is essentially doing the same thing, right? Anybody remember the word they use for that? It starts with R. So ChatGPT, when you sort of ask some weird things and when you say, hey, I don't like the way you're answering, answer it like this and all, that's basically user feedback loop. And they use reinforcement learning to adapt the system which is already trained. You would want something very similar, right? You would want your models to be in the production, and then when the user gives you feedback that, hey, you're doing something wrong, the model should be automatically adapted to that feedback, right? Now, there's one very critical thing that we need to understand. Most machine learning systems are not deterministic in nature, right? They're probabilistic in nature. So you cannot expect, unless you have a feedback loop, you cannot expect the systems to go as is. Now, these are the three major focus areas of MLOps: continuous integration, continuous delivery, and continuous training. Now, these are the words, some of these words are being borrowed from the DevOps world. That's why you have a ops word there. Um, and they have done this very shamelessly. So it's not something that, they came up with on their own. So for people who are coming from DevOps, you would sort of at least sync a lot with what we are saying here. But let's talk about these concepts from machine learning perspective. And this is pretty much all you can take from this session. If you understand how to do these things, and again, like I said, these are not tools, technologies, or some kind of an open source, right? You would have to either do this on your own, or you would have to use some or the other cloud services to achieve this. So continuous integration essentially means that you're integrating every ML asset, right? So when I say ML asset, can somebody tell me what are different ML assets or artifacts that we produce as the whole cycle? So let me start with saying data is one, your ML code or model code is second. What else? Features, predictions, what else? Parameters of the model, like which parameters are we using, what else? The metrics, right? The accuracy, bunch of different metrics. Anything else? So these artifacts have to be integrated all the time. Let's take a simple example. Somebody said that data bias or data drifting is a huge issue when you do machine learning model, right? So if you were to automate that process, you need something that sort of integrates all the time, right? So the moment something new comes up, let's say there's a delta between the data through which you have trained the model and the new data that came, let's say 2 months down the line, you would want a pipeline to automatically trigger a new training mechanism that incorporates this new data, right? And this is pretty much what we mean by continuous integration, that you need to have a way where your models are already sort of integrating again and again with the new changes in the system, like whatever that delta is. Now, one thing to note here is, of course, you can point out and say that, hey, can we just do it blindly? Like, shouldn't we do some kind of a check whether the data is good or bad? Or are we deviating too much from the previous data? If we are, then we might need to do everything from scratch. So this is what we sort of try to take care of: continuous integration. Continuous delivery is, again, like I said, in this case, think of continuous delivery as bunch of models which is continuously being ready to be delivered at scale, right? So again, think Uber, for example, right? So their fare prediction or any kind of predictions that they do, there are thousands of models that sort of goes in the backside of it, and there's data that changes every day, and they have to do this availability of the models all the time. So which is again something that we look into from a continuous delivery point of view. And continuous training, as the name suggests, means that once you have figured out the best versions of the models, you take a step back, you let the pipelines take care of you, which means that you want a scenario or a phase where everything is working on its own. You're not even part of the whole cycle of MLOps, right? So that's the maturity phase, and we'll come to 3 levels of maturity phase. But if I were to give you another thing to think about, is that eventually you want your machine learning operations or machine learning workloads to go in a direction where you just sit and see a dashboard where everything sort of happens automatically. So the data comes, it automatically gets trained, tells you what's wrong, what's right. It also sort of auto deploys if it sees better accuracies and all, and everything has happened on its own. That's like the dream state. Of course, it's not that easy to reach there, but these are the three important keywords to keep in mind, right? Any questions on this? These three things are very important. If we understand this, then rest everything sort of makes sense or connects. So integration makes sure that you have everything ready for it to train. And continuous training essentially means that you're continuously training something. So the moment new data comes to you, you're not waiting for you to perform some experiment, right? Because typically that's what we do, right? So we do snapshot of historical data. Then let's say somebody or the client or the customer gives you new 6 months of data, right? You don't want you to be part of that process. You want that automatically my model should keep on training with the new data. Of course, with, like I said, it should not be blindly, it should be with a some kind of a rule that we are trying to follow. This is where again the feedback loop that we talked about comes in very handy. So there are two things. One is, of course, you would know from a date perspective. So it's as simple as when you again use ChatGPT, and sorry for using the example of ChatGPT, but you have seen examples of it. But there's always a cutoff of the model, right? So my model has been trained till, let's say, March 2023, for example, right? Now, of course, let's say you're 3 months down the line, you already know that your model doesn't have any feedback which has been sort of sent to the model anything later to the March of 2023, correct? So one is, you know that you are already lagging 3 months of information back to the model. Now you could question that, hey, but maybe there's no information, there's no new information which I should be passing it. This is where the human feedback or the business feedback comes, because they might say, hey, in last 3 months, I'm seeing sudden rise in my customer cases which are coming from fraud, right? So which means they might tell you that, hey, can you please go back and retrain the model because it looks like your model is not performing well, or there's something wrong because the information is not matching to what is I'm supposed to do on the ground, right? So typically banks, for example, take care and measure the support ticket or the customer calls that are coming. So if they see a sudden rise, they go back to the data science team saying that, hey, your model is doing something wrong. Can you please go back and check? Because we are getting a feedback where people are either flagged for wrong fraud or they are frauds and not being flagged. Is there? Yeah. So the automation doesn't mean that there is no involvement and it is like completely automated in a sense that you cannot change things. What automation here refers to is that you have visibility to stop and start things. So you know when is something happening and you have built rules into it. So it's not like suddenly everything is happening on its own. You have inbuilt rules into that where you're saying, hey, only deploy model if you cross my, let's say, threshold of accuracy greater than my previous model, which is, let's say, 95. So it doesn't mean that all models will be published one by one, right? Ideally, no, because that happens before when you're doing the first manual intervention, right? So EDAs are essentially a part where you're trying to understand your distributions and all of those things, right? So you assume that, hey, I have enough information of that and I've built features around it. You will do the manual cycle of EDA when, again, like your models are going stale, right? Suddenly you're seeing that, hey, my support ticket were supposed to be at 2% and suddenly I'm getting, let's say, 8% increase. That's when you go back manually to your EDAs of the new data saying that, hey, there's something which is very different from what I have seen in my original data. So continuous integration, because again, EDA is something which is very human, right? So we can't sort of do the automation. However, just to give an example, people do in the monitoring of the model, they do integration of your statistical values and all. So there are some which you can automate in EDA. There are a lot that you cannot because it depends on our analysis. Feature engineering is part of the integration because you want the features to be automatically build, deployed. And that's why there's a product called Feature Store, because you want that to be available all the time. There's a very famous paper by this name. I don't know how many of you have read this. Anybody who have read this? Hidden Technique? I see one. Anybody else? I would say please go read this paper. It's called Hidden Technical Debt in Machine Learning Systems. It's available online. This was published in way back 2015 or 2016. This talks about how Google has faced huge challenges when they have done sort of machine learning productions, and what typically goes wrong when you sort of do these production. These are some of the things which goes wrong, and these are things which you should be thinking about. So what you need to remember is that machine learning of lately, all the way we have learned and the way we have deployed, we have never thought about these things, right? We have never thought about monitoring. We have never thought about verification of the data. We have been very sort of focused on, hey, load a data, do the EDA, build features, run model, maybe do PyCaret or something like that, and then just build an API. That's pretty much what most of us have been doing from an ML perspective. But what Google sort of says, and it's nothing unique that they say, many companies say the same, which is that you have to start thinking machine learning from a system perspective, because your models are going to go at some point, they are going to go and connect with different systems, right? Somebody is going to use those models to use something at the in the end, right? So you need to think about these systems rather than from a end-to-end perspective to more ML systems and ML stuff. So let me quickly again, you can take a screenshot of this slide. These are some papers that are worth reading. Um, these papers sort of again talk about the same thing, which is what goes wrong when you do production. So, and by the way, the presentation will be available, so you can also sort of refer that. Okay, so let's quickly jump to the most important part of the presentation, which is what are the different maturity levels and how do you sort of go step by step, right? So like I said when we started, like the dream state is to have everything automated and you sit idle and have dashboards in front of you, which is what level 2 is, at least in the sense of automation. What most of us and most of the companies are at level 0. There are very few companies, including Google, internally in a lot of products, they're still at level 1. Level 2 is some products, but not all products, and many companies have still not reached to the level 2. It's still something which is very new. So we'll talk about these three levels, what it contains, what are the different keywords that you need to remember. Again, there is this paper, this is a white paper by one of my colleagues, Donna Shoot. You should go again, just Google search and see Practitioner's Guide to MLOps white paper. Do read this. This paper sort of talks about this maturity phases and what is that you should think about in this sense. So this is the first process. Again, we have already seen this. All of you are aware of it. It simply means whatever you have been doing in machine learning sort of comes from a level 0 or the manual process stage. Now, one thing you can clearly notice is that this is the API, right? So we don't care too much beyond the API. As long as we have model API, somebody is a consumer and they are sort of using it, we are good. But one thing that you will start noticing is that there's something called as experimentation, dev, test, and then staging, pre-prod and prod, right? These are words which are coming from the DevOps world. This has nothing to do with ML or MLOps in general, but we are sort of borrowing these names because you have to again think of machine learning deployments from a point that there is an experimentation phase of your models. So you sit with your fellow data scientists and data analytics and all, and you sort of spend 6 months doing notebooks and all. And in no way I'm saying you should not do that. That's the most important process. You should still do it. And this is what the experimentation dev part of things are. But then the moment you move from this to this, there are certain things that you need to keep in mind, and we'll see that what are those things. But this is your level 0. Level 0 again, like I said, you have script, notebook driven. There's a continuous integration, automated code test, and data validation. So this is again happening all manually. These are not something which you're doing sort of automatically at this point. Let's look into the challenges, because this is where we know that what we need to do in the next stage, right? So human error due to lack of automation, models do break. Why do they break? Because your data changes. There's a lot of expectation that might change. There's no active monitoring. You have not built any dashboard to look into what goes wrong, right? There's no active retraining cycle which you're doing. So because you're doing everything notebook driven and there's just one API, you have not been focusing on the retraining cycle, right? And then the last is no consolidated ML technology. You're not sort of saving the assets anywhere. There's no artifact which is being saved. Now we go to the level 1, right? So let's look into the workflow for a moment and then we'll see what it is. And one thing again, focus on the experimentation and the dev staging prod, and then the final prod that you see in the bottom. Let's look at this for a moment and then we'll sort of try to understand what's happening here. What is the difference do you see now that you've seen it for a few seconds? So there's a source code repo. Okay, good. What else? So there's a continuous feedback. Good. What else? What else do you see? So there's a pipeline deployment. And in fact, you will notice that there is an automated pipeline as well, which means starting from data extraction to validation to prep to training. You know, if I have to give you a basic example of it, think like the single lines of code that you've written in notebooks, you've just converted them into scripts of Python. That's it. So this, when we say automated pipeline, imagine that you've written like a main function and you're like, hey, call first function, which is data extraction, it extracts data, then go to the next function, which does some data validation. So you're basically, whatever 6 months you've spent doing manual things, writing line by line, you've just converted everything into pipeline. Again, somebody tell me, why would that be an important step? Like, why would you care to create a functions out of everything? What will it help you do? It's repeatable, right? So that's the pretty definition of why we write the functions in the first place, right? Because you want things to be reproducible. You don't want to do this thing again and again. You don't want to run one single cell, or maybe if there's an automation of the notebook. And this is what level 1 differs, right? So you have many of the same things that we have done in the level 0. It's nothing new. But then there are some small things which are sort of added, right? So you have source repository, so it's like just saying you're pushing everything into GitHub, so you have a proper structure. You have different automated pipelines, so you have functions which are sort of doing step by step of all the automation. Again, the biggest component is the performance monitoring. So now you have something where you're monitoring the performance. You're saying, hey, I'm going to make predictions, but I need a way to measure that because I should know when I should do something about the model that I've built, right? Again, your models is not being retrained automatically in this stage, right? This is where we go to the bigger stage, which is the second maturity. So in this, again, most of the things will be sort of roughly the same. You will see the same level of components, but you will start seeing some of the components like CI build, test and package pipeline components, deploy pipelines. So this is where, you know, tools like Jenkins, a lot of companies use Jenkins. There are many other tools which are available. There are cloud specific tools which are going to help you do this automation, right? So again, just to give you an example, imagine that because you're doing performance monitoring, right, and suddenly you have an upshoot of people who are filing for support tickets and all. Those support tickets, the moment they increase by, let's say, 5%, there has to be a trigger in your pipelines which should say that, hey, please do all of this one more time by integrating the new data, retrain the model, and if the model gets you greater than some, again, you have defined those rules, redeploy the new model because I'm seeing the performance going down. But do remember that all of this is happening automated based on the rules that you have written. It's not happening on its own, but you have written rules. You're saying, hey, if I see 5% upshot, do this. Only deploy if you see greater than this or that, right? So this is your third level, which is very hard to achieve, but it sort of is something which is dream state, which you should keep in your mind that data scientists cannot spend time doing things manually, right? So this presentation again, we'll stop in a moment, but this presentation sort of has a bunch of these assets that you can take a note of. You'll get the access, so please go through it. What I want to sort of quickly show you is the Vertex ecosystem. So again, I'm not trying to sell you something, but just there are many other tools which can sort of help you do that. One neat little surprise that I was telling you is the Vertex ecosystem now will have the generative AI integration that will come, and I'll show you a quick demo of it, how it looks, and what are the things that you can do. But apart from all the other components of the Vertex AI, which is MLOps, and you can do all the training and all of those things, you will have sort of model garden, which is, think of, you know, enterprise Hugging Face. Like you've all used Hugging Face at some point. Think of Model Garden as something which is like enterprise Hugging Face, where all the Google models are available and all the other open source models are also available. And then you have Generative AI Studio, so anything to do with large language models, you can sort of do that integration. So This is the, you can take a snapshot of this. Again, this is the whole ecosystem of Vertex. You can see that Vertex has all of these components. That's why I was saying that if you want to do these automation, you need certain of those smaller tools which are available to you. So for example, feature stores, ML metadata, explainable AI, model registry, model evaluation, how do you do model monitoring, uh, building the pipeline. So pipelines are something which again some of you might have already heard. So your KFP pipeline, your Kubernetes Kubeflow pipelines and all are essentially the same pipeline because you need something which scales automatically, right? So I'm going to stop here. Let me see if I can play that video for you.
Welcome to Data Cloud and AI Cloud. We're at the start of the new era of AI emergence. To bring generative AI to enterprises, we introduced two platforms. GenApp Builder is a brand new offering that brings together foundation model with the power of search and conversation AI to enable enterprises to develop new generative AI apps. And Vertex AI is our end-to-end unified ML development and deployment platform. Now is its biggest update yet with generative AI support. A range of foundation models are made available to developers and data scientists. Developers benefit from easy API access, and data scientists have a full suite of tuning options for customizing these foundation models. Let's recap the three categories of use cases we saw today. First, when we think about how to make online interaction more conversational, more human-like, and helpful, the potential for improving customer experiences, engagement, and loyalty is immense. Second, the ability to intuitively interact with complex data across sources means you can better enable your teams with business and industry insights. Third, content generation gives people the ability to turn their creative ideas into targeted content rapidly. This is all made possible by bringing together foundation models, conversation AI, and enterprise search. Our partners are ready to support generative AI at every.
Yeah, so go ahead and check this out. This is again something which is coming along with the ML Ops component. So again, like I said, you'll have the access to the presentation. Please look into the ML Ops maturity stages and happy to connect with anyone offline. Thank you.